Hello, welcome back. Today we're going to go over an application of integration, which is in fact a second fundamental theorem of calculus. So the given function is capital F of x, which is given as an integral where the top limit is in fact x. So it's the integral from -5 to x e to the t dt. Well, first we're going to try to integrate this integral, treating that as a definite integral, and then try to write f as a function of x. Once we're done with that, we're going to sort of like try to apply the second fundamental theorem of calculus to this function, which essentially means that we're going to take the derivative of this function. But since we integrate this in the first part, then we're just going to take the derivative of that and see how the same derivative comes out of the second fundamental theorem of calculus without integrating this integral. All right, in part A, let's try to come up with the antiderivative of e to the t here. So e to the t has the antiderivative e to the t, and remember that when we have the definite integral, we use the bracket notation here and we place the lower limit here, -5, and upper limit here. And the way it works is that we first plug in the upper limit for t, so this becomes e to the x, and then subtract e to the lower limit, which is e to the -5. All right, so this is in fact what f of x is. I want to remind you about the second fundamental theorem of calculus. Essentially, it says that the derivative of f, if it's defined through an integral, is the function inside the integral, so it's e to the t, evaluated at the upper bound, so it's just e to the x. Okay, and as you see that the lower limit is a number, -5, that doesn't have any role in taking the derivative of this function. So essentially what we're doing is just replacing the t expression of the function here with the x expression of the function. So f prime x is e to the x by the second fundamental theorem of calculus. And as you see that this value should be exactly the same as taking the derivative of this function, which is obtained by taking the antiderivative of this function here and using the upper and lower limits. And in fact, if you take the derivative of this function, it's still e to the x, and this term has a derivative 0. As you see that I got the derivative of f prime exactly the same as this one, but just through second fundamental theorem of calculus, which does not require to take the antiderivative of this function here, as you see, and it sort of like bypasses all the definite integral calculation over there. All right, this is the end of the short video, which was talking about the application of the second fundamental theorem of calculus. I'll see you in another video. Bye.